golf cart requires a power of 3,000 watts to travel at a constant speed of 5 meters per second. What forward force is required to keep the golf cart moving at this speed? All right, so we see that we're given power and we're given speed, or in this case, it should be the same as velocity. And we want to figure out force. So we want to relate power, force, and velocity. But when we go to our quantitative relationship sheet, we're probably going to see this, and we're going to see that it doesn't exactly relate power, force, and velocity. But this is still useful to us because we see that power is defined as work over time, and of course we know what work is: force times distance. So let's rewrite power equals force times distance over time. Now let's just write distance as delta x, and then if we just rewrite that, delta x over delta t. What does that sound like? Well, of course, that just sounds like velocity. So we can see power equals force times velocity. And now we can just plug in our numbers. And when we divide by 5 meters per second, let's actually go ahead and rewrite watts. So watts equal joules per second, and joules equal Newton times meter. So Newton meter per second divided by 5.0 meters per second. So we can do some dimensional analysis, and we see meters per second cancel and leaves us with 600 newtons for our force, and that's a perfectly sensible unit of force, and we have answer A.